All right, so we just solved equations, right? And so now what we're going to do, is that serious? What? Oh, I did, didn't I? Oh, that's all right. I started recording. I'll go over the homework after I finish this. This shouldn't take too long. Famous last words. All right, so let's make sure this works. Yeah, it looks okay. All right, so we've done equations before, so guess what we're going to do now? Things that are not equal but are what? Are unequal, right? Or unequal. But they call it inequalities. I don't know why in English we say unequal, but we say inequalities. That's just one of the quirks of our language. So we call them inequalities, which means they are what? Not equal to each other. That's right. So if I compared two numbers to each other, right? If I said, okay, I'm thinking of a number and you had to guess that number, you basically have three choices, right? As far as if you guess it, if it's bigger, if it's smaller. Okay? Wouldn't you agree with that? That's called a trichotomy. That's a big word for you. Why try? Because you got three choices. That's right. So if I thought of a number and you think of a number, you could guess it right on the nose, right? So you could guess a number that's equal to it, or you could guess a number that is what? Higher than it, or a number that is lower than it. Agreed? All right. So basically, that's what we're dealing with when we talk about inequalities. So we need a symbol. Well, you know the symbol for equal. We've used that forever. And there's your symbol for equal. All right. What about if it's smaller than? We don't say smaller than though, do we? Yeah, we say less than in math. So less than looks like this. And then we have another one. What's the other one? Starts with a G. Greater than. And that looks like this. Now, I'm assuming you're reading from left to right, okay? So that would be less than if you're going from left to right, or greater than if you're going from left to right. So let's put some simple numbers in here. Let's put 2. 2 is equal to 2, all right? This is silly, but I'm going to do it anyway. 2 is what? Less than, hold on, give me something. Don't give me something crazy, 7, all right? And then 2 is what? Greater than, give me something else. 1, okay, all right. I was hoping you'd give me a negative or something, but that's okay. All right, so that's what that stuff means. Do you know why less than looks like that? Because we basically took equals and then we just see the distance from here to here. It's the same exact distance, isn't it? For an equal sign. Yeah, so an equal sign, if I drew it correctly, I'm a little slanted here, but an equal sign, it should be the same exact distance between both of those line segments, agreed? But look what we did here. We tilted one this way, we tilted the top one down here, we tilted the bottom one right here. So what's the distance between these two compared to these two? It's what? It's less than, all right? So that's why it's less than. And then with greater than, okay, the distance between here and here, right, is bigger than the distance between here and here, so that's greater than. And when you're a little kid, your teacher teaches you what? The alligator, right? Yeah, eats the bigger number and all this stuff. I mean, that's fine if you want to remember it that way, but this is really the way that I look at it, okay? Less than, greater than. Everybody good with that? Yeah. And even the book even talks about the trichotomy property. I'm not going to write it down. Oh, here's another one. You could also say less than or what? Or equal to. So you put a little line underneath. That means it could be less than or equal to something. And we're going to put some variables in here eventually. Or greater than what? Or equal to. So less than or equal to, you put a little line under. Greater than or equal to, you just put a little line under. That's what it means. So, and we're going to do a little bit of graphing today. It's very easy graphing. It's not X and Y graphing. It's just in the X direction. Let's just talk about this. Let's talk, well, let's see. See, if I would have taken my notes on this, I wouldn't look to see what I want to leave out and what I want to include. But I messed up on my lesson planning, so that's okay. So let's do this. Yeah, we'll do a little graph since I mentioned graphing. All right, we'll put a graph right here, and let's just graph something very easy. Let's say x is equal to 3. All right, so you put some numbers on here. That's good enough. Tell you what, let's put 3 right in the middle. All right. A lot of times we put 0 in the middle, but the 0 doesn't always have to be in the middle. I'm just going to put it right there. So if I go to the right of it, talking integers now, what's the next integer after 3? That's 4, 5, 6. And then this would be what? 2, 1, 0. And it could keep going negative if we wanted to. But if I wanted you to graph, if I asked you to graph x equals 3, what would you do? You'd come over here on a number line, you'd find 3, what would you do? Put a dot. Let's not say dot though. What is it? You just had geometry, a circle, or a point, right? Let's put a point. Or you put a big old circle, however you want to say it. Dot, circle, point, I'm fine, any of those things. But that means what? X equals 3. What if you said, let's go white again. What if you said x is less than 3? So I'm going to get rid of this dot right now. Okay. So I got to find all the numbers that are less than 3. So could I put a dot at 2? Is 2 less than 3? Yeah. Could I put a dot at 1? At 0? At any negatives? What about the stuff in between? Yeah. The stuff in between is also less than 3. Could I put a dot at 4? No, because 4 is not less than 3. So how do I show all the numbers, all the real numbers, not just the integers? How do I show all the real numbers less than 3? Okay, I don't put really a dotted line. Well, we're going to put an open circle. Okay, we're going to put a, I'm in red. All right, so I'm going to put an open circle at this number. Why is it open? It doesn't equal 3. That's right. It does not include 3. That's why it's open. All right. Later on, I don't know if this book does it later on, but when you get to pre-calc, they'll definitely do this. They'll do this. They'll put a parentheses instead of an open circle. We'll still use the open and closed circles right now, but eventually they're going to change the notation a little bit, make it a little bit more, I don't know, sophisticated, I guess, right? It just means the same thing as an open circle, okay? But we'll keep it open, and then you just kind of shade everything to the left. Just make it a little bit thicker, right? Just make it kind of fat like that, okay? And that means everything to the left of 3, but does not include 3. It gets as close as possible to 3. 2.9999999, I could keep doing all day, but it never hits 3, okay? But it's everything to the left. So that's the graph of that thing right there. We good with that? What if I put a little or equal thing under either? Now what do I do? Just shade in the circle, okay? So if I shade in that circle, that includes 3. It's a solid, it's a closed circle, okay? Remember what I said later on in math? Instead of an open circle, use a parentheses. Well, instead of a closed circle, use a bracket. That's what they'll do eventually. We're not going to do it right now, but I just wanted to show you to see what we'll look at. I don't know if they do that in this book or not. First time I've taught out of this book, so I'm not really sure. Okay, doke. What if, let's pick another color and thing. What if I said, what is if x is greater than, let's just go 4. We'll keep it on our number line. If you were to graph that, x is greater than 4, and I asked you to graph that, what would you do? Open circle at 4, and then shade everything to the right. I've seen some people do this. They'll go up like this and like that. That's okay. I've seen books do it like that. I kind of like just making it kind of thick. Or some people will do like kind of squiggle like that, all right, just to show it includes all those numbers. All right, I'm fine. I don't have like a preference. Well, I kind of do. I think I like the shaded in thing, but the squiggle thing's fine. The up and over is fine. We're good with that. Make sense? All right, that's easy enough. Let's talk about some rules for these inequalities. This is pretty important. Basically, except for one circumstance, the rules for inequality are the exact same rules that we had when we did equality. For instance, if I had x plus 2 equals 7, all right, super basic problem. Hunter, you getting all this? Or is this too easy? You don't have to pay attention? All right, not with your head down, you're not. So Keep your head up. Is that good enough? All right. So look, x plus 2 equals 7. So what's the rule? You subtract 2, x equals 5. Yes? But what if you had this? What if you had x plus 2 is greater than 7? Does that change anything? You solve the exact same way. You subtract 2, x is greater than 5. Well, let's see. All right? Think of a number line. That's got 5 on it, but I'm just going to... You don't have to write this number line, but I just want you to look at it and think about it, okay? So here's 5 right there, okay? So let's see if any number that's bigger than 5 actually works for x. You see that? So give me a number, not some crazy 1 million something. Give me a small little number that's bigger than 5. 10. All right, let's put a 10. Let's see if it works, okay? We got to put it back into what? It's not our equation, but into our what? Inequality. So let's put it back in. 5 plus, or what did I say, 10, right? Put a 10. 10 plus 2 is 12. Is 12 bigger than 7? Yeah, so it works. All right, let's pick a number a little closer to 5. 6. Put a 6 in for this. 6 plus 2 is 8. Is 8 bigger than 7? Yes, it is. What if I put a 5 in there? 5 plus 2 is 7. Is 7 bigger than 7? No, it's not. So that means it's open, right? You with me? And then everything to the what? I'll squiggle. All right, everything to the right. What if I picked a number smaller than 5, like a 4? Put 4 in there. 4 plus 2 is 6. Is 6 bigger than 7? No. So that doesn't work. That's why it's not shaded. You got it? That's why only the stuff that's shaded will make that thing work. Okay, it will satisfy the inequality. That's how math people say it. All right, it satisfies the equation or the inequality, or it just makes it work. All right. All right, that's good enough for that. Subtraction's the same. All that good stuff. Let's try another one. So for addition and subtraction, it doesn't matter if you add or subtract. The inequality stays exactly the way it was. But what if you're to multiply? Let's try that. So like 3x equals, we'll stay small, equals 15. Oops. Well, you know what that is. It's what? X equals 5. But let's do an inequality. What if I said 3x, let's go less than this time, is less than 15? Then what's my answer? Divide both sides by 3. X, keep the inequality the same, and then make that a 5. Let's see if that works. You don't have to do this every single time you do an inequality. I'm only doing this one time just to show you why the rule works. That's all I'm doing right now, okay? So there. So again, here's 5. Let's pick a number less than 5, and it should satisfy that inequality. Let's pick a number less than 5. 3, all right? Let's pick a 3. Put it in for this. 3 times 3 is what? 9. Is 9 less than 15? Yes. Does 3 work? Yes, it does, okay? Let's pick a number that's not less than 7. All right, let's pick 7, put it in here. 3 times 7, 21. Is 21 less than 15? No, it's not. So nothing to this side works, does it? But everything to this side works. So is my rule fine? Do I still keep the inequality the same direction? Absolutely. All right, here's something that's a little different. Watch this. What if I said negative 3x is less than 15? Here's the one time, well, 1a. There's a 1a and 1b, okay? Here's the one time where this doesn't work. If I divided by negative 3 here and divided by negative 3 here, and then x, watch, don't write this down. I'm just going to write this down because what I'm going to write down is not correct, okay? If you want to write it down and make sure you write, this is not correct, all right, or not right. Watch, what if I kept the inequality the same? What if, big if, doesn't work, okay? But what if I kept it the same? What would this be? Negative 5. So let's see if it works, all right? Pick a number that's what? Less than negative 5. So here's negative 5, way over here, negative 6. Let's put a negative 6 in for this. Is negative 6, wait a minute, yeah, let's put it right here. Negative 3 times negative 6 is what? 18, positive 18. Is 18 less than 15? No. So this doesn't work, does it? So I got to change this thing up. What do I got to do to it? I got to switch the sign. Exactly right. So when you divide by a negative or multiply by a negative, that's why I said 1a, 1b. Remember I said that earlier? Okay, if you multiply or divide by a negative number, you've got to change the direction of the inequality. All right? So am I dividing by a negative number? Yes. So I change it from less than to what? To greater than. Now let's see if it works. So give me a number that is bigger than negative 5. Yeah, let's do negative 4, okay, and see if it works. Negative 3 times negative 4, positive 12. Is 12 less than 15? Absolutely. It does work, doesn't it? Right? And you could try a whole bunch of numbers if you wanted to, but that's the rule for inequalities. So you work them exactly the way you would if it was an equal sign, with basically one exception. I say basically because it's multiplication and division, but you get the idea, right? So with one exception, the only time you change the inequality is if you multiply or divide by what? A negative number, okay? You can multiply and divide. We did it right here, and it still worked, right? We kept the inequality the same. So you can divide or multiply by a positive number, and it doesn't change anything. But when you multiply or divide by a negative number, that's when you got to change the inequality. That's the biggest thing about this lesson. That's the hardest thing about this. Maybe the graphing, but the graphing probably is not that hard for you. Everybody okay with that so far? Yeah, so let's do an example. All right, so it's 4x plus 12 is less than 8. 4x plus 12 is less than 8. All right, and it says solve it and graph. I'm going to write that right here. Solve and graph. That's supposed to be an and symbol. Anyway, solve it and graph it. So let's solve it first, okay? Because we're not going to graph it the way it is. We want to get x by itself before we graph it. So we do it just like it's a regular old algebra problem with an equal sign, but it's not an equal sign, all right? So here we go. What do? Subtract 12, subtract 12, all right, and then 4x. Now, I subtracted a number. Does that change my inequality? No. I can subtract all day long, and it still stays that. 8 minus 12 is negative 4, okay? Now, get x by itself. We divide by positive 4. Does that change the inequality? No, because we divided by a what? A positive, all right? So the inequality stays the same, and that's negative 1, okay? If you wanted to put it back in to see if it works, give me a little small number that's less than negative 1, an easy number to work with. Negative 2. Negative 2 is less than negative 1. Let's put it in here. 4 times negative 2 is what? Negative 8. Negative 8 plus 12 is 4. Is 4 less than 8? Yes. So it does work, doesn't it? So I'm okay circling that. But they also ask you to graph it. So we do what we just talked about a few minutes back. Put the little graph. If it's less than negative 1, look, I'm going to put negative 1 out here like this. Just put a couple 3, something like that. So negative 1, negative 2, negative 3, negative 4. A lot of times I'll put 1 to the right, so that would be a 0. So what's our graph going to look like? Less than negative 1. What kind of circle do we put? Put an open circle, because it's just less than. It's not or equal to. So it's an open circle. And then we shade in everything to the left. Put an arrow on that shading so you know that that's your graph right there. So you can choose any number to the left of negative 1, and it's going to satisfy this inequality. Make sense? Yeah, that's easy stuff, isn't it? Still Algebra 1, isn't it? Yeah. When are we going to do Algebra 2? I don't know. Maybe one day. All right, let's do example 2. I'll let you try this one. So we're going to solve this, and we're going to graph it as well. So solve, this one's a little bit more intricate, a little bit more stuff to it. Minus 6 x plus 2 equal, or is greater than or equal to, greater than or equal to x minus 4. I'll give you about a minute. All right. So what I want you to do is I want you to solve it. Don't worry about the graphing right now. We'll just graph it together. But I want you to solve for x. Yes. It is a 6. That's a 6. So it's 2 parentheses x plus 9 minus 6 parentheses x plus 2 greater than or equal to x minus 4. All right, go ahead and work on it. Give you 1 minute. Go. It says 6. They just asked it, and I just repeated it. Even when I wrote it, I said that's a 6. There we go. Now it looks like a 6. So you got a little distributor property going on first, right? Add some like terms. Then you start moving stuff over to the other side, or to both sides, I guess, from one side to the other. And if you want to graph it, if you're finished now, before the minute's over, well, too late, minutes, the minute is over. Did you get anything yet? So what did you get, Max?
2, 3, and
2, 3. I don't know. What is that? 2 what? Looks like a 27. I don't know.
No,
23? 2, 3?
That's 2.
It's just a 2.
Yeah.
2 is... Oh, I see what you did. Yeah. Yeah, you could write it like that. There's a little bit better way to write it. Write it with the x first. So switch it around. Write the x first. But that is correct, yes. All right, so let's do this together. You ready? 2x plus 18 minus 6x minus 12. Did you guys remember to put the minus for that one? Okay. We haven't even moved anything over, so I don't have to even worry about changing the direction of that inequality. All right, add some like terms. So what do you get? Negative 4x plus what, 4? Again, I still haven't moved anything over. Let's get the x's on the same side. Let's put it on the left-hand side. Is that all right? You could put it on either side. It really doesn't make any difference. You can always switch it at the end. But I usually like to put stuff on the left-hand side. So I'm going to subtract an x here, subtract an x here. Let's take this positive 4, move it to the other side. Now, all I've done was subtract. Yeah, I've subtracted 2 things. Do I change the inequality when I subtract? No. My inequality does not change right now, okay? Because all I did was subtract stuff. And I can subtract stuff all day long. It doesn't change the inequality. So that canceled out. This canceled out. What do I got here? Negative 5x. Is that right? Greater than or equal to. Did I do something wrong? I did something wrong. What did I do? My math? You didn't stop me? That's a negative 4. This is a 6, not a 4. Why are you letting me write wrong stuff? Should be taking care of me here. So what is it? Plus 6. Plus 6. Oh my word. You're letting me hang myself, weren't you? Okay. So, let's get rid of this whole mess right here. All right. I just can't add 2 numbers together or subtract 2 numbers. All right, so is that right so far? Yeah, it's plus 6. That's still a minus 4, isn't it? Yeah. Now it's right. Negative 4x plus 6, right, is greater than, there you go. So subtract 6, and now we get a minus 10. There we go. That looks better. Now I fixed it. All right, that canceled. All right, now here we go. We've not had to move that inequality at all. So now look at our last step. I got to get rid of a negative 5. How do I get rid of the negative 5? Divide by a negative. Okay, I've got to divide by a negative. So what does that do to my inequality? What does that do to that? Flips it. So now what's it going to be? Less than or equal to 2. So that is what you're going to graph right there. Sorry about the mix-up there. Does that make sense? Yeah. If I could just go 18 minus 12, I would have been fine. Now, we're going to graph it. Graphing should be the easy part now. Wouldn't you agree? Once you got x by itself. So 2, and it's less than, so I'm going to put 2 over here, all right? And it's less than, I'll put 2 or 3. So what's less than 2? That's a 1, that's a 0, that's a negative 1. And then, oops, then we come over here. Let's use this orangey color. It's less than or equal to. So what does that mean we do? That's right, fill in the circle. Solid. It's a solid circle, okay? And then we shade which direction? To the left, because it says less than. That is less than to the left. This is nice and shaded in. There's my graph right there. Gio.
Oh, I got
Well, that's because you didn't change your inequality. Okay? Because you divided by a negative 5. Remember, anytime you divide by a negative, because negative 4x minus 1x is negative 5x. Okay?
I put it on to the other x. I got positive x.
Well, do it the way I did it. All right. So just, did you write down my steps? Write down my steps. That's what you should be doing. All right? Or at least checking yours. So negative 4x minus 1x is negative 5x. And I subtracted 6, that gives me negative 10. Divided by a negative 5, when I divide by a negative, that's when I change the inequality. That was the whole purpose of me talking all about that stuff over here, okay, with my rules. All right? Do they have another one? I think they have one more. Let's flip it over. Yeah, they got one more. It's really the same. Oh, I see what they're doing. Okay, I see what they're doing. So let's do this one. I think this is a good one to do. This is example 3. And it says solve and graph again. So here it is. We'll work this one together, okay? Negative 2x plus 9. It's less than negative 2. 3x plus 4. So something weird happens on this one. This is why they saved this one to the end. Okay? So here we go. Let's work it just like we did the other one. So distribute the 3. That's negative 6x plus 27. Make sure you check my arithmetic. All right? Make sure I don't make any dumb mistakes. What's this? Negative 6x minus 8. So far, so good. Let's get the x's on the same side. Let's put them on the left-hand side. So what am I going to do? I'm going to add a 6x. I'm going to add, yeah, what happens? That's correct. So look, that cancels. I'm left with 27 less than. That cancels. Where's my variable? Where'd my variable go? And plus it says 27 is less than negative 8. Is that true? Is 27 less than negative 8? No, that's not true. So we say this particular inequality has what? No solution. So there's nothing. There's no number I could put in for x that's going to make the left side less than the right side. There's no number that exists. Okay? Everybody see that? So weird stuff like that happens from time to time. And part B, they have a part A, part B. Basically, it's the same kind of thing, so I'm not going to hit that. So really, today was as easy as the other day when we did the linear equations, right? We did just solve for x kind of thing when we had an equation. The only thing different, well, we had to graph today. That was a little bit different. But what was the only thing different as far as our rules go? When we do what? When we multiply or divide by what? A negative, right? Okay, listen to me. Everybody's listening, right? Did you write it down in your paper? I didn't actually write it in my notes. But if you multiply or divide by a negative number, you change the direction of the inequality. All right, so if it was less than and you divide it by a negative, you change it to greater than. If it was greater than, you change it to less than. Okay, but that's the only situation. It's the only time where you change the inequality. When you're dividing or multiplying by a negative number. We got that? All right, that's something people tend to forget when they start doing these things. But the inequalities, some people don't like them because it looks kind of weird, but really it's just the same as an equal sign. It's no different. If you like the equal sign, inequality shouldn't be a big deal, except for that one, difference. All right, well, let's see. I didn't give you very many, did I? Should probably give you more, shouldn't I? No. I kind of thought you would say that. So let's call this 1-6A, and it's page 32. It's on the lesson plan thing I gave you. Page 32, 9-16. There it is. That's your homework, and it is due tomorrow. And there's no quiz. Again, the lesson plan says there's a quiz, but I don't know what I was thinking. I was probably thinking of another class or something, I guess, when I wrote that in there. So there you go. That's it. Have it done for tomorrow.